Earth wasn't the first attempt. There's evidence, strong evidence, that before our solar system looked anything like what you see in textbooks. There was a different configuration. Larger planets. Closer to the sun. And then something came through and cleared them out. Not an asteroid. Not a rogue star. Jupiter. You're standing on what's left after the cleanup. 4.5 billion years ago, the solar system didn't have structure. It had a disk. Gas, dust. Ice, all of it swirling around a young Sunday. That was still gathering mass, still figuring out how to sustain fusion without falling apart. And in that disk, planets were already forming. Not the planets we know. These were different. Models suggest they were super-Earths, worlds with 10, maybe 15 times Earth's mass. Rocky cores wrapped in thick hydrogen atmospheres. They formed fast, close to the sun, where material was dense and collisions were constant. This wasn't chaos. This was construction. But construction in a gas disk comes with a problem. The disk doesn't just sit there. It moves. It rotates. And anything massive enough to carve a path through it starts interacting with the gas in ways that don't lead to stability. They lead to migration. And migration, in the early solar system, meant one direction. Inward. When a planet moves through a gas disk, it's not gliding. It's plowing. The gas ahead of it gets compressed. The gas behind it gets pulled along. And because the disk is rotating faster closer to the sun, this creates an asymmetry. The planet loses angular momentum. Not quickly. Not catastrophically at first. But consistently. This is called Type 1 migration for smaller bodies, Type 2 for gas giants. The names don't matter. The consequence does. Any planet massive enough to disturb the disk starts spiraling toward the star. Slowly at first. Then faster. The process feeds on itself. The closer the planet gets, the denser the disk becomes. The denser the disk, the stronger the drag. There's no equilibrium here. No point where the planet settles into a stable orbit and stays there. The gas disk is a countdown timer. And unless something intervenes, the planet reaches the sun. Not in millions of years. In hundreds of thousands. If this sounds impossible to you, hit the like button, because the early solar system didn't care about giving planets time to stabilize. Jupiter formed farther out. Past the ice line. Where water vapor froze into solid grains. And allowed planetary cores to grow fast enough to start pulling in hydrogen and helium before the disk dispersed. It became massive. More than 300 times Earth's mass. A gravitational anchor in its own region of the disk. But it wasn't stable. Jupiter started migrating. Inward. Through the same mechanism that was already dragging smaller worlds toward the sun. Except Jupiter wasn't small. It was a bulldozer. As it moved through the inner solar system, it encountered them. The super-Earths. The planets that had formed first. They didn't survive the encounter. Jupiter's gravity didn't need to hit them directly. It just needed to pass close enough to destabilize their orbits. And once an orbit destabilizes in a gas disk, there's no recovery. Some of the super-Earths were flung outward, into eccentric orbits that either ejected them entirely or sent them spiraling back into chaotic regions where collisions finished what Jupiter started. Others were pushed inward. Into tighter and tighter loops around the sun, where the drag from the disk accelerated. Their cores began to heat. Tidal forces stretched them. The hydrogen atmospheres, thick protective layers, were stripped away by the sun's radiation. and by the sheer violence of their inward spiral. What was left wasn't a planet anymore. It was molten debris. Glowing slag tumbling through a disk that no longer had room for it. And then they hit the sun. Not all at once. Over tens of thousands of years, maybe longer. One by one. The super-Earths that had formed in the inner solar system were erased. Not by collision. Not by external impact. By the same process that had allowed them to form in the first place. The gas disk built them. Then it consumed them. Jupiter kept moving. By the time it reached what we now call the asteroid belt region, it had crossed into territory that should have been stable. But stability doesn't exist when a gas giant is migrating through your orbital zone. The inner solar system, the region where Earth would eventually form, was being gutted. And Jupiter was still moving inward. Models suggest it may have reached as close as 1.5 astronomical units from the Sun, closer than Mars is now. Close enough that if it had continued, there would be no rocky planets left. No asteroid belt. No region where small bodies could survive long enough to coalesce into anything stable. The disk would be empty. But Jupiter didn't reach the Sun, something stopped it. Not friction. Not a physical barrier. Another planet. Saturn. Saturn formed later than Jupiter. Farther out. It was smaller, only about a third of Jupiter's mass, but it was still massive enough to open its own gap in the disk and start migrating inward. And as Saturn migrated, it began to catch up. This is where orbital resonance enters the process. When two planets migrate through a gas disk, their orbital periods can synchronize. If Saturn's orbit took 3 years while Jupiter's took 2, their gravitational interactions would repeat in a predictable pattern. That's a 2:3 resonance. And once that resonance locked in, the dynamics changed. Saturn wasn't just following Jupiter anymore. It was pulling on it. Gravitationally anchoring it. The combined interaction with the gas disk shifted. Instead of both planets spiraling inward independently, the resonance created a feedback loop. Jupiter's inward migration slowed. Then stopped. Then reversed. This is the grand tack. The moment when the solar system's largest planet, deep into the inner system, turned around and started moving back out. It didn't happen fast. The reversal took time, maybe tens of thousands of years. But it was enough. Jupiter retreated. Back past the asteroid belt. Back toward the outer system. And as it moved outward, it left behind a region that had been cleared, compressed, and rearranged. That region is where Earth formed. If you're starting to see why this channel doesn't treat planetary formation like destiny, subscribe. Because what comes next only gets harder to reconcile. When Jupiter moved outward, it didn't undo the damage. The super-Earths were gone. The inner disk had been stirred. Truncated, stripped of most of its mass. But it wasn't empty. What remained was debris. Smaller bodies. Planetesimals that had survived. Because they were too small to interact strongly with Jupiter's gravity. Or because they were in regions that the migration had passed through without complete destabilization. And in that debris field, something started to happen. Accretion. Not the same kind of accretion that had built the super-Earths. This was slower. More fragile. The collisions were less violent. Because there was less mass to work with. The bodies that formed weren't gas-rich giants. They were rocky. Smaller. Earth, Venus, Mars, Mercury, their second-generation planets. Built from what Jupiter left behind. This explains something that had been difficult to reconcile. Earth's mass is small compared to the super-Earths we see in other star systems. Most rocky exoplanets discovered so far are larger than Earth. Much larger. 5, 10, 15 Earth masses. Earth isn't the norm. It's the exception. And the reason it's the exception is because it formed in a region that had already been cleared once. There wasn't enough material left to build something bigger. Jupiter's retreat also explains the asteroid belt. The belt sits in a region that Jupiter passed through twice, once inward, once outward. Each pass disrupted the local disk, preventing a planet from forming there. What's left is fragments. A graveyard of material that never finished coalescing. The belt isn't a failed planet. It's a scar. And Earth sits just inside that scar, made from scraps. The Grand Tack is a model. A good one. It fits the evidence we have about Jupiter's composition. The structure of the asteroid belt, the isotopic ratios in Earth's rocks. But it's not the only model. There are alternative explanations for why the inner solar system has the structure it does. Some involve different migration timings. Others suggest Jupiter never migrated as far inward as the standard Grand Tack scenario requires. We don't have a recording of what happened 4.5 billion years ago. What we have are simulations. Constraints from meteorite chemistry. Observations of exoplanetary systems where migration clearly happened. The evidence suggests the Grand Tack is likely. But likely isn't certainty. We also don't know how many super-Earths were destroyed. The models vary. Some simulations show 2 or 3 large planets clearing out before Earth formed. Others show more. Or fewer. And we don't know exactly when Saturn's resonance kicked in. If it had happened slightly earlier, Jupiter might not have migrated inward as far. If it had happened later, Jupiter might have reached the Sun. Timing matters. And we don't have the precision to reconstruct it perfectly. What we do know is this: Earth formed in a disk that had already been processed, cleared, reduced. If you think this uncertainty makes the process less real, share this video to challenge that assumption. So Earth is debris. A second attempt built in the ruins of a much larger system that didn't survive. It's smaller than the planets that came before it. And smaller than most rocky planets we find around other stars. Because it formed from what was left after a gas giant tore through the inner solar system and then reversed course just in time. That reversal is the only reason we're here. But here's the part that doesn't close. Jupiter destroyed worlds. It cleared out the inner system. It had the mass to dominate everything in its path. But it didn't have enough mass to become something else. It sits out there now, 300 times Earth's mass, larger than everything else in the solar system combined except the Sun. And yet it's not a star. It never ignited. It never crossed the threshold where gravity compresses hydrogen hard enough to fuse. It had the power to erase planets, but not the power to ignite. Does this lack of closure make you uncomfortable? Let me know in the comments.